So this large pearl was found in the Philippines, and then it was placed on a spring scale, okay, to know the weight. Now, there a problem is given you that the scale has a spring, okay, it has a spring, okay, and that spring had a spring constant of 362 newtons over meter. Uh, the spring constant represents how stiff something is, okay, or how much strength it could, for example, it could support. Okay, so in this case, the spring constant is 362, and they are telling you that the platform is oscillating. When it oscillates, okay, oscillations is part of a harmonic motion, and it can be measured in cycles, or in this case, it's already given you the frequency. Remember that frequency represents how many cycles per time unit are done during a specific time. For example, that could be 1 second. So the frequency is given in this problem, and they're asking you to find the mass of the pearl. Okay, so what we do in the first place, we start by writing the data. Okay, so in the givens, we have the spring constant. The spring constant, it is abbreviated as, or it is denoted by the letter K, okay? And it's 362 newtons over meter. And it's giving you the frequency, that is 1.20 hertz. The problem is asking you to find the mass of the pearl. This is your unknown, okay? So according to the formulas that I gave you, we can find the mass with the following equation. Okay, before I go into the mass, oh yes, I'm going to write the equation for the mass, and you will notice that we're missing something. Mass is equal to is equal to the period divided by 2 pi and all this is multiplied times the constant K. Okay, so according to the formula to find the mass, what am I missing? I already have the constant and the 2 and the pi. So where's my period? I don't have it. I don't have my period, so what can I do? In the presentation I sent you for this topic, I wrote 2 extra useful equations that are for frequency and period. Those are additional. One of those equations says that the period is equal to 1 over frequency. The other tells you that the frequency can be calculated as 1 over the period. From these two equations, which one should we use to find the period? The first one or the second one?
The first one.
The first one, okay? It is very obvious. So let's work with this. Let's find the period for this exercise. I'm going to delete this one because we're not going to use it. So I will get the period by just dividing 1 over the frequency, that is 1.20 hertz. Remember that hertz is a compound unit, okay? That is 1 over second. How much is the period?
0.83.
0.83. And because I'm talking about period, the units are seconds. Okay, now, how do I know the units are seconds? Okay, all you do is you can write this as fractions. Okay, you can say that 1 is the same as having 1 over 1 in a fraction. Okay, and you can say that hertz is equal to 1 over seconds. So when you have a division of fractions, what you do in the end, you multiply the two values that are the outer values, okay? And you will have a 1 times seconds that is going to be divided by the inner values, that is 1 times 1. So in the end, this is going to be 1 divided by 1 times the seconds. And you remember that we just ignore 1 as a coefficient or as a denominator. So in the end, your final unit is going to be just seconds. You don't need to do this procedure in the quiz, but it is necessary that you know where the seconds are coming from. It's not something that Martinez made up one day. Okay? So, I'm going to delete this process. Or I don't know if you want me to leave it there. But I will delete it because no one cares. Okay, so now we can apply the formula to find the mass. So we said mass is going to be equal to my period that we just found, which is 0.83 seconds, divided by 2 pi raised to the second power multiplied times the spring constant. Now in your calculator, how are you going to do it? 0.83 divided by 2 divided by pi, which is shift. Okay, like that. You get the answer. Now raise it to the second power, you get this one. And then you multiply times that constant, that is 362. Did you get the same mass as me?
Yes.
6.32 kilograms. And because I'm talking about mass, don't forget that the unit should be the kilograms. And that is the answer. Here I just put K and I didn't put the value. The value is 362 newtons over meter. And that's the answer that you get. As you can see, the application of the formula is very simple. But just remember that you have to solve everything that is here in this parenthesis first. And the answer you get, you raise it then to the second power. Once you have the result, you multiply times the spring constant. Okay, now in the second problem, from the second topic, I have what we know as wave speed. Okay, so who wants to help me to read the problem?
The world's largest guitar, which was built by a high school student in Indiana, has strings that are 9.9 meters long. That fundamental vibration that can be induced on each string has a wavelength equal to twice the string length. If the wave speed is a string is 9 times 10 to the second power meter per second. What is the frequency of vibration?
Thank you. So we're talking about the world's largest guitar, okay? In this case, we're talking about wave speed. Okay, remember that speeds need a medium to travel. In this case, the medium is the string of the guitar. So, just for you to know, bueno, I don't know how to draw guitar. Bueno, no sé ahora. Bueno, kind of. Puedo hacer más, lo siento. Y bueno, let's say that's the guitar, okay? So, it's not the guitar itself the one that matters. We care about the medium of the wave. In this case, is the string. The string, when you play the guitar, the string begins to vibrate. So we care about the length of the string. So more or less, the strings are like this, pretty much like this in the guitar. Okay, and here it has like some pins where the string is being like attached to it. Well, kind of, it's not perfect. Okay, so the problem is telling you that the string has a length of 9 meters. Okay, so the length of the string is 9 meters. Not the guitar, the string. Okay, now the data that is given in this problem, oh, beautiful guitar, I know. The data that is given in this problem is the string. The string is 9 meters long. Okay, and also if you continue reading, it says that it has a wave speed of 9 times 10 to the second power meters over second, and they're asking you to find the frequency. So you write the data. The length of the string is 9 meters. The wave speed is 9 times 10 to the second power meters per second. They're asking you to find the frequency. But there's another data that is given in this problem. There's one data that is given in this problem and it's not written in numbers. It is written in words. Take a look. Have you found it?
The wavelength.
Okay, what does it say about the wavelength?
That is twice the string length.
Aha. That is the most important data in the problem. Because if you don't read this like for real, okay, if you don't read it for real, like if you really care, you wouldn't notice that that data is over there. It is provided. The problem tells you that the wavelength is twice the strings length. Okay, that's what the problem is telling you. Twice the strings length. And this, if we turn it into a mathematical equation, twice is being replaced by the number of 2, and the strings length we know it's L, okay? The value that is 9 meters. So you can get the wavelength as 2 times 9 meters, which gives you in the end 18 meters. That's very important for this problem. The reason is because for this problem you use wavelength, you don't use the length, okay? That's why that sentence over there is very important. Now, what is the equation that we use to calculate the speed of a wave? What is the equation that we use to calculate the speed of a wave? The speed of a wave is equal to frequency times the wavelength. And the problem is asking you to find a frequency, okay? This is the unknown. So isolating the frequency, you will have that frequency is equal to the wave speed divided by the wavelength. So right now what you do is you just replace by the givens. 9 times 10 to the second power meters per second divided by the wavelength, that is 18 meters. So there, if you just put the 9 meters, the answer is going to be incorrect. Even though the topic is very easy, the formula is very simple, but not reading the word problem will lead you to commit mistakes. So how much is this?
50.
Remember that you
50.
cancel the meters here, and the answer will be 1 over seconds. Okay, so this is going to be 50, 1 over seconds, and this is nothing more than hertz. Okay, this and hertz are the same, so you can just write 50 hertz, and that will be it. Easy topic, interesting word problem. Okay, now we're going to the last one. Who wants to help me read to read this problem? Sorry.
Car Walker of a twin reportedly snored loudly with a report intensity of 4.5 times 10 square of negative 8 W meters squared. Suppose the intensity of Walker's snores are measured 1.60 meters from her mouth. What is the power associated with the record snore?
Okay, so we're talking about a person. Thank you so much, Juan. We're talking about a person. This girl, Walker, well, she's a student woman, okay? Uh, a Swedish woman, sorry. Well, she's interesting because her snores are very loud. So if you are a very sensitive person at night, you want to be any close to her because she is noisy when she sleeps. Okay, that's something that people cannot control. But in the end, she has a record. Okay, she is pretty intense. Her snores are pretty loud. So what do we know about her snores? It says that has an intensity of 4.5 times 10 to the negative 8th power watts over square meters. And it says that suppose the intensity of Walker's snores are measured 1.6 meters from her mouth. So remember that for the sound intensity, we need the distance from the source. So this will be my other data for this problem. Now, I'm going to write my givens. They are giving me the intensity, and that is 4.5 times 10 to the negative 8th power watts over square meters. It's giving you a distance from the source, which is her mouth, okay? Because when you snore, the sound is coming, of course, from your mouth. So the distance from the source, from her mouth, is 1.6 meters. And they're asking you to find the power. How much power? How much power? How powerful her snores are. Okay, so I gave you an equation to get a power for intensity topic, and the power is calculated as intensity, okay, times 4 pi times the distance from the source raised to the second power. That is the formula, and we just need to replace by the givens because we don't need to do any conversion here. In case that you need to do conversion, like for example, that the distance isn't fit, for example, you have to do a conversion before. But this is not the case, so we continue, we apply the formula. We say power is going to be equal to 4.5 times 10 to the negative 8th power watts over square meters times 4 pi times r, which is 1.6 meters, to the second power. Now in your calculator, this will be 4.5 exponential negative 8 times 4 times pi times 1.6 raised to the second power. And then you put it in scientific notation. That for me is like this. Did you get the same answer as me? I got 1.45 times 10 to the negative 6 power. Now here I'm going to cancel the square meters with these meters raised to the second power from there. So my final unit for power is going to be watts. Did you get the same answer as me? Did you get the same answer as me?
Miss,
No.
how
Yes.
you convert
Yes.
to scientific notation?
You can write it in scientific notation, or if you didn't, you should have this answer. 0.0000145 watts. Both are correct, okay? Both are correct. But to change it in your calculator, just press mode. Follow me, okay? Because the calculator that I'm showing you in the screen is probably different than yours. So follow my instructions. Mode, mode, mode. Then it tells you that psi, which is scientific notation, is in the key number 2. So press 2. And it says that you have to choose a number of digits that this is going to show you between 0 and 9. And I want my answer to be in 3 digits because it is scientific notation. Okay? So you press the 3 and you can do the problem now. 4.5 exponential negative 8 times 4 times pi times 1.6 squared. Did you get the same answer as me now?
Yes, thank you.
Yes, Miss. Thank you.
Okie dokies. You got, you said, well, in your case, send me your video on how you do it in the calculator. Maybe I see that you are committing a mistake, okay? Send it to me to WhatsApp after the class is over so I can help you with that. Okay, so this is intensity of sound wave. As you can see, it's pretty much very simple. Now, for the last topic, that is harmonics, who wants to help me reading it? Okay, the tallest load-bearing columns are part of the Temple of Amun in Egypt, built in 1270 before Christ. Find the height of these columns if a standing wave with a frequency of 49 Hz is generated in an open pipe that is as tall as the columns. The sixth harmonic is generated. The speed of sound in air is 334 meters over second. So remember that for harmonics, we need some specific, well, we need the instrument to be specified. So in this case, the problem tells you that we have an open pipe. An open pipe is just the same as saying open pipe. Okay? If it's closed, it's gonna tell you it's an open closed pipe, or it is a closed pipe. Okay? But in this case, the problem tells you that it is an open pipe. Now, there are some givens in this problem. It tells you that you need to find the height of these columns. Okay? Okay, so you need to find the height. This is unknown. And then it's telling you that the frequency is 49 Hertz. Okay, so you have the frequency of 49 Hertz. Then it tells you that the frequency is as tall as the columns. This is very nice. So, it is trying to tell you that the column of air that generates, that sound is going to be the same height as the column. So if you find the L, if you find the length of the instrument, you're gonna find how tall the columns are. So in this case, by height, I need to find actually the length because it says that it is as tall as the columns. Okay, so I'm gonna put it in different color. And then it says the sixth harmonic is generated. The sixth harmonic and the speed of sound is 334 meters over second. So the sixth harmonic is generated, so it means that the harmonic number is 6. Okay? And therefore, the frequency is this is the sixth frequency that the problem is giving you. And the speed of the sound is 334 meters over second. Now, in an open pipe, the formula that we have to use, okay, the one for length, because we have a open pipe, we need to use this equation to calculate the length. Okay, length is going to be equal to n, the harmonic number, times the speed of the wave, divided by 2 times the frequency. Okay? You know that the harmonic number is 6 because this is the 6th frequency, and it's multiplied times 334 meters over second, divided by 2 times the frequency of 49 hertz. How much is this? How much is this?
20.45.
20.45 meters. And with this, you solve the problem.